So, hello students. So we'll continue our sampling topic. Our topic would be types of sampling. So sampling is of two types: probability sampling and non-probability sampling. So if we talk about the probability sample is a method of sampling that uses the random selection so that all units or cases in the population have an equal probability of being chosen. That is, all the set of population or all the respondents will get an equal chances of selection. Non-probability does not involve random selection and methods and are based on the rationale of probability theory. So basically we'll do two types of sampling techniques: probability and non-probability. Sometimes it is also referred to as random and non-random techniques. So probability is when each and every respondent has equal chances of selection. Non-probability is when there is no equal chance of selection. So probability sample is defined is of four types further. It is actually divided into four parts. The very first is simple random sampling, second one is systematic sampling, third one is stratified, and fourth is missing here, that is cluster sampling. So stratified random sampling is further classified into proportionate and disproportionate. Cluster sampling is further classified as one stage, two stage, and multi stage. Okay. So, and non-probability sampling is also four types: convenience sampling, quota sampling, judgmental sampling, and snowball sampling. Convenience samples are actually where we are very easy. It is not difficult to collect the data and it is very affordable as well as convenient. So sample is selected from elements of a population that are easily accessible. Purposive sampling, that is judgmental sampling. When you think of some purpose before collecting your data, for example, if you are doing study on the four-wheeler brands and especially of Maruti Suzuki, so the very first question will be, do you own a car of Maruti Suzuki? So you are getting your questionnaire filled with some purpose. So that is why it is known as purposive sampling. You chose who you think should be in the study, that is upon the researcher's discretion. Then third is quota sampling. Fourth is snowball sampling. We'll do one by one in this chapter. So, what is the basic difference between probability and non probability sampling? There on the left side, there are comparison factors, and here on the right side, it's a difference between probability and non probability sampling. If we talk about the population elements, so complete list is necessary in the probability sample. What do you mean by complete list here? That is, we are giving the equal chances to every responses respondent to get selected. So there should be some list, or there should be a method through which we can select it properly. The non-probability, no, not necessary to have some to having a list, because it is based on our judgment, researchers discretion, and as per the convenience. Information about sampling unit: each unit is identified, and in non-probability we need detail on the habits, activity, traits of consumers, etc. So in random sampling we need some techniques and we need some skills, but little skill is required in non-probability. Time requirement: probability is very much time consuming because we are going through some technical method. For example, in stratified random method, we frame stratas, then we collect the sample from each data. Or we if we say about the cluster sampling, similarly in the cluster sampling we have to get a representative set of data from the whole cluster, that might be like Mumbai, Delhi, or on the basis of the geographical indicators we can make a cluster. Then okay, l- low time consumption in non-probability sampling, because it's very easy to collect the sample from your neighborhood stores, if you are doing research on retail stores. Cost per unit sample moderate to high in probability and very low in non-probability. It's unbiased approach because we are going by some technique, but in non-probability it's very biased because we are doing it as per our comfort. Sample representativeness, it's very good in probability and it's assured, but in non-probability it's suspect, undeterminable. We are not sure that our sample is good or not. Accuracy and reliability, we are computed with the confidence intervals. In my previous video, there was confidence interval is clearly mentioned, that is at 95% or 99%, that how much you are or researcher is sure that you is confident that your data is error free, so that is at 95 or 99%. But in non-probability sampling, we are not considering any confidence interval or sampling error. Measurement of sampling error is done by statistical measures in probability, whereas in non-probability there is no true measure available. So we'll do firstly simple random sampling. Simple random sampling is is used when population is small, homogeneous, and readily available. So all subsets of the frame are given an equal probability. Each element of the frame thus has an equal probability of selection. For example, a table of random number or a lottery system. Chit system is used to determine which units are to be selected. Advantage, easy method to use, no need of prior information of population, equal and independent chance of selection to every element. What is the disadvantage of this method? That if sampling frame is very large, this method is impracticable because it's not easy to go by a chit system or lottery system in net. So if sampling frame is large, this method is impracticable. It does not represent proportionate representation. So we are not actually doing it in the systematic way. So that's why it doesn't represent the proportionate representation. For example, here you can see in this slide, so simple random sampling is done by this method. Every subset of a specified size from a population has equal chance of being selected. We are by any hit and trial method. We are saying the 20th element, 27th element, 29th element, 32nd, 32 element, 40th element. So that is every respondent or every unit has equal chances of get selected. Suitability. This method is suitable for small homogeneous, randomly selecting units from sampling frame. Random means mathematically each unit from sampling frame has an equal probability of being included in the sample. For this, we follow some stages in the random sampling. So firstly, we will define the population, our target population. Then from the target population, we'll develop a sampling frame. Sampling frame is list of your sampling units from where you'll collect your data that is determined by your sampling frame. So then to that list, you will assign a number, each unit a number. Then randomly select the required amount of random numbers. So systematically select random numbers until it meets the sample size requirements. For example, you are having a list of 1 to 100 students, right? So that is our sampling frame. Population is students, and sampling frame is 100, list of 100 students. So we are assigning number 1 to 100 to 100 students, and then we are saying that every 20th or after 20th we are saying we are selecting 30th. Then after 30th we are selecting 32, 33, 36, 39. Then in from 40s we are selecting 45, then 49. So we don't know, that is upon the researcher's discretion, not discretion actually, that is a prompt choice of the researcher. So that is unbiased, and that is not having any kind of partial thing. Then replacement of selecting units. Sampling schemes may be without replacement or with replacement. So, for example, if we catch fish, measure them, and immediately return them to water before continuing with the sample. So, this is with the replacement design because we might end up catching and measuring the same fish more than twice. However, if we do not return the fish to the water, this becomes a without replacement design. Similarly, if we talk about the consumers, suppose we are doing study on the consumer's perception on retail stores. So that is from the Delhi NCR area. So once we have recorded the responses of the consumers, then we are again getting in touch with the same consumer, and we are recording their responses twice. So that is wrong. That is actually known as sampling with replacement. But if we have data, we have proper data, and we have a proper thing that is mentioning that this consumer has already filled our questionnaire, so will not go back to that respondent. That is sampling without replacement design, and that is error free and is good. It is better than sampling without replacement. Oh, it is better than sampling with replacement. Sorry. Now come to the second random method, second probability technique, that is systematic sampling. It is similar to the simple random sampling, but the difference lies is here we have a certain set of criteria. That is, we are selecting. We are systematically selecting the random sample. That is like every 20th sample is getting selected. After 20 it's 40, then after 40 it's 60. So we are actually giving some system, we are giving some sequence to the selection. That is why it is known as systematic sampling. So here you can read about the process of sampling. It's same as simple random sampling, except the the fraction we are providing to collect the sample. Then systematic sampling has some advantages. It is This sample is very easy to select. Suitable sampling frame can be identified very easily. It evenly spread over entire reference population. It is very cost effective method. Disadvantages: it may be biased because it's a hidden periodicity in the population that coincides with that of selection. Each element does not get equal chance. We are saying it, but it is not actually done in reality. Ignorance of all element between two elements. So here is an example of systematic sampling here: 8th, 28th, 48. That is, I already told you, that is from the sampling from or the list from all population members, we are selecting every 20th person. So that is known as systematic. That is, we are following some sequence. Then come to the third thing, third probability technique, that is stratified random sample, and it's very important. The population is divided into two or more groups called strata according to some criterion such as geographic location, grade, level, age, income, and some samples are randomly selected from each strata. So we can say we are framing the stratas from the homogeneous stratas from the heterogeneous set of population, that on the basis of some characteristics. That characteristic might be location, grade, level, age, income, anything. For example, if I talk about the children, so I have taken the sampling population of children, and that is of 6 to 12 years. So how can I make strata out of it? So I can make it 6 to 8 years, then 8 to 10 years, and third one is 10 to 12 years. So in this example I have made three stratas: 6 to 8 years, 8 to 10 years, and 10 to 12 years. Now from all the stratas I'll choose my sample, and I'll take the sample from each strata and get my sample completed. My data collection get completed after it, after I get the collection data from all the three stratas. Similarly, here one example is given: That Caucasians list of clients, then strata and random subsamples. Uh, so it's a population. Then suppose it's expats population in somewhere. So three sets of strata: Caucasians, African American, and Hispanic American, and we're collecting a sample from the each strata. Stratified random sampling is of two types: proportionate and disproportionate. Proportionate means equal or in some proportion, that is in the ratio of 2, in the ratio of 3, that we are drawing from each stratum. That is, suppose we are drawing two respondents from each strata. That is your proportionate. Disproportionate is we are not giving any proportion representation to the strata. That is known as disproportionate. Stratified sampling advantages. It is enhancement of representation to each sample, very high statistical efficiency. It's a very good method and it's very easy to carry out. So it is basically error-free method. But disadvantages: classification. We are not able to classify properly that which strata is actually that it is actually strata or not. Time consuming, expensive, knowledge of composition and distribution of population. Cluster sampling. The fourth one, that is the last from the probability sampling technique. Cluster sampling is in two-stage, example of two-stage sampling. First stage is a sample of areas is chosen. Second stage is where the sample of respondent within those areas is getting selected. So similarly, as in stratified sampling, we are getting we are framing straight here. We are framing clusters from the heterogeneous set of populations, and that strata or that clusters are homogeneous units. Similarly, in the strata, but the difference lies here is that the straight we are getting sample from each strata, but in cluster sampling we are considering it as sampling unit. That is, we are doing study on the whole cluster. All units from the selected clusters are studies. That is nothing like a strata that we are getting the data from each strata. So sampling units are groups rather than individuals in cluster sampling. So here you can see in the picture the circle one, that is your cluster. The second red circle, that is cluster, that is also a cluster. So this is basically for the geographical regions. For example, if we talk of Mumbai, Delhi, or Bangalore. So these are the cities which we are actually we are doing sampling, cluster sampling here, because if we say we are selecting the metro cities from the whole population. So suppose your first target population is metro cities population. So how do you frame a list for it? That is your sampling frame. So from this list of metro cities, you have selected the three cities, that is Delhi, Bangalore, and Mumbai. So Delhi, Bangalore, and Mumbai is having sharing this different characteristics. So that is basically heterogeneity. There is homogeneity, that these are the metro cities, but the population in the Mumbai, population in Bangalore, and population in Delhi is heterogeneous in nature. There is nothing like homogeneity in homogeneity in the clusters, but in stratified sampling there is a homogeneity in each strata. So advantages: cut down on the cost of preparing a sampling frame. This can reduce travel and other administrative costs also. Disadvantages is it's higher for a simple random sample of same size. So cluster sampling is actually done at various stages also. So like I already told you, that is the two stage. For example, randomly selecting 20 hospitals from the list of all hospitals in England. That is an example of cluster. Multi stages, we are doing it in the different stages. The very first stage is random number of districts chosen in all states, then followed by random number of their talukas, tehsils, villages, and the stages will be units. Units will be houses. So it is actually working in the at the three stages. Difference between strata and clusters, I already defined it properly, but still, whatever it's written, I'll explain it to you. Although strata and clusters are both non-overlapping subsets of population, they differ in several ways. All strata are represented in the sample, but only subsets of clusters are in the sample. With stratified sampling, the best survey results occur when elements within the strata are internally homogeneous. However, with the cluster sampling, the best results occur when elements within the clusters are internally heterogeneous. If we take example of children, that is of 6 to 12 year, 6 to 8 year, 6 to 8 to 10 year, 10 to 12 year. So that is a three strata we have made from an example. But in clusters we have taken the example of metro cities: Delhi, Mumbai, Bangalore. So here are three clusters and there are three stratas. The population within the 6 to 8 years of children are very homogeneous, right? But the population within Mumbai, within Delhi, and within Bangalore, that is very heterogeneous. That is the very first difference within the stratas and cluster. And the second thing is, in the cluster all the units are your samples, but in the strata it is not. Third thing, clusters are already predefined. That is, we know about the metro cities, but stratas are formed by majority, in major majority cases, are framed by us. So thank you, students. So this is all about your probability sampling. So in the next lecture, we'll do non-probability methods, non-probability sampling technique.